Welcome back, everybody. Today we are going to wrap up our trigonometry section for Algebra 2. Trigonometry gets not too much harder, but there are a lot more aspects to it. There's graphing, there's solving equations, there's using identities. But again, I wanted to give you guys the basics, okay? And today we're going to wrap those basics up with a very powerful tool called reference angles, and we'll talk about that now in a second. I just want to give you one brief review. I know we've had a lot of review in the trigonometry. I put up the same stuff over and over. There's a reason for my madness. I want to make sure that you guys understand this, okay? Remember, when we're talking about trigonometry, we're talking about right triangle geometry, basically, what's going on here. And when we have an angle, let's call it theta. In this case, it's angle A or theta. Remember that across the theta, whoa, that was pretty cool. Across the theta, that's the opposite. The opposite is the y value. Okay, if you look over at this guy, that theta goes across y, all right? The side immediately next to it is the adjacent, that's the x. On this triangle over here, the x is the adjacent. And the hypotenuse is always across the 90. The hypotenuse is always across the 90. That's r, or the hypotenuse, okay? This P is a point on the circle that is part of the revolution of the angle. Remember that when we're talking about trigonometry, gentlemen, please remember that we're talking about a circle. So as this radius moves from point to point, those are different locations on the circle, correct? Well, that's what this point P, x, comma, y represents. It represents the y value and the x value when a point is on when an angle reaches a certain point on the circle. Okay, you guys with me so far, right? Okay, we've learned this, I don't know how many times, SOHCAHTOA. Sine is opposite over hypotenuse, but remember, when we're talking about a Cartesian plane, like this guy right here, okay, talking about a Cartesian plane, we're talking about y's and x's. So that's why I have this y over r. Remember that y is the opposite, r is the hypotenuse. Cosine, adjacent over hypotenuse, or x over r. Tangent, opposite over adjacent, or y over x. Cosecant is the reciprocal of the sine, so it's hypotenuse over opposite, or r over y. Secant is the reciprocal of the cosine, so it's hypotenuse over adjacent, or r over x. And cotangent is the reciprocal of the tangent, which is adjacent over opposite, or x over y. Little hint, remember, tangent equals the sine over cosine. It doesn't take a genius to understand that y, remember that's the opposite, that's going to be the sine, x is the cosine. Remember that on a unit circle, points on the unit circle, the x value is the cosine and the y value is the sine. Right, guys? Everyone's with me so far, right? Okay. Let's move on. Find the exact values of the 6 trigonometric functions of theta contains the point 5, negative 2. So let's go ahead, 5, negative 12. Sorry, guys. 5, negative 12. Let's go ahead and use the y-axis as negative 2s. Okay, we're going to go by intervals of negative 2. So negative 2, negative 4, negative 6, negative 8, negative 12 right there. And on the x-axis, we'll use intervals of 1. So 1, 2, 3, 4, here's 5. Okay, 5, 12, guys, is the point on this circle. So there's some circle. And there's an angle, okay, that is traveling on this circle. Actually, let me use this guy. Yeah. There's an angle that's traveling on this circle, okay? And when this angle travels, it hits different points all along the circle, correct? Are you guys understanding this? So this particular angle stopped right there. Are you feeling me? Well, make a right triangle now, guys. Bam. Isn't that 5? Because it's 5, 12, x, y, right? And this over here, the y is negative 12, correct? All right. My theta's right here. So I want to find the exact trig values. Yes, Pythagorean theorem, or you could have learned your Pythagorean triples. What would this be? 13. Very good. It's a 5, 12, 13 triangle. Come again, sir? Yes, because remember, even if it's negative, 5 squared plus negative 12 squared is still going to equal 13 squared, sir. Because negative 12 squared is 144. So I want to find all 6 trig functions now. So let's do this, guys. What's the sine of theta? Come on, guys. Negative's opposite over hypotenuse. What's the cosecant of theta? 13 over negative 12. I'll make it a little neater now. What's the cosine of theta? Adjacent over hypotenuse, negative 5 over, not negative. Pay attention. 5 over 13. Sorry about that, my bad. And the secant, which is its reciprocal? 13 over 5. Very good. And then last but not least, tangent, opposite over adjacent, negative 12 over 5. And cotangent, 5 over negative 12. Does that make sense, boys? Is that a unit circle? Absolutely not. How can a unit circle be with 13 as a radius? The unit circle only has a radius of 1. From the unit circle is where I get my triangles, my right triangles. And then I can expand those as I want. And they have a ratio. You have to remember those ratios, guys. Okay? The reason why the special triangles are so important is because they work no matter what circle you have. Everyone with me so far here? Okay. Remember your quadrantal angles, guys. I know we've seen this before 100 times. Yes, I understand that. I need you guys to understand this, though, for real. On the unit circle, every point on the circle represents the x value is the cosine, and the y value is the sine, okay? So if I tell you, give me the cosecant of 270 degrees, well, cosecant is the reciprocal of the sine. The sine of 270 is negative 1. So that's negative 1 over 1. So reciprocate it. 1 over negative 1 still going to equal negative 1. Got to know your quadrantal angles, okay? And from this unit circle, remember, guys, you get your special angles. You have a 30, 60, 90. The 30 is the smallest side, value of 1. 60 is the small side times radical 3. So 1 times radical 3 is radical 3. The hypotenuse is 2 times the small side, so that's 2. And then you have your 45, 45, 90 triangles. And the sides are equal, so they're 1 and 1. And the hypotenuse is the side times square root of 2. So that's going to be 1 times square root of 2 is square root of 2. These two triangles and this quadrantal circle here give you everything you need to solve a multitude of problems without touching a calculator. Okay? Without touching a calculator. But if you don't know how to set this up, my friends, it's going to be very hard for you. Or you could memorize that table that we saw. And you guys didn't seem too happy about memorizing all of those values, which I understand. So you have 2 choices, though, and only 2 choices, unfortunately. You either memorize the 2 triangles in the circle and come up with your values quickly because you know what you're doing, or you memorize those values. Either or, there's no other option, unfortunately. I'm sorry, guys. May I continue? Okay. Find the values of the 6 trigonometric functions of an angle in standard position that measures 270. Okay. Oh my God. Oh, what do I do? You don't stress. You make a little unit circle. You know 270 is down here, right? So is that 0, negative 1? Isn't 0 the cosine? Isn't y the sine? So let's check it out, guys. Sine of 270 equals? Sine of 270 equals? Sine of 270 equals negative 1. And then the cosecant, which is its reciprocal, equals negative 1 as well. Whoever's saying 0, no. Negative 1 has an invisible number under it that is a 1. We have gone over that 100 times, my friends. We've got to put it together. What is the cosine of 270 degrees, gentlemen? 0. Yes, the cosine. X, 0. Done. And what is the denominator of 0? 1. Thank you. So what is the secant of 0? Very good. Secant of 270 is going to be undefined. Because when you take 0 over 1 and reciprocate it, it's 1 over 0. Tangent. Remember, tangent is sine over cosine. So what's the tangent of 270? Undefined. Very good. And what is the cotangent of 270? 0. Remember, cotangent is the reciprocal. So it's cosine over sine. 0 over negative 1 is 0. Is this making sense, boys? Awesome. Let us continue. Okay. Reference angles. Let me get rid of these drawings. Let me show you what to do here. All right, guys, this is it right here. This is it. This is what puts it all together. This is what makes you a monster in geometry. For any angle theta, okay, written theta prime, is the positive angle made by the terminal side of an angle and the axis of symmetry. This theta prime is called the reference angle. When you draw a full angle, okay, that's angle theta. But when you're calculating the values, you're not using the full angle. You're using what's called the reference angle. And let me explain how this reference angle works. Okay. Let me get a different color here for this so I can match this up. Well, actually, let's do first the first colors. Okay. I'm going to first do the reference angle in quadrant 1. Okay? This angle right here. I'm in quadrant 1. In quadrant 1, whatever theta you have, whatever main angle, that is your reference angle. In quadrant 1, you have nothing to worry about. The angle is the reference angle. That's what we've already been doing. 30, 60, 45, those are all inside of the first quadrant. You make your little triangle. Your theta is your reference angle in the first quadrant. Okay? In the first quadrant. You with me? Yes or no? Okay. Next, let's do this orange guy. Okay. We're going to focus on this guy now, okay? This orange theta is this right here. The whole theta, the whole angle is this. But we don't calculate with the whole theta. We calculate using the theta prime. So what happens here? When you get to your terminal side, guys, drop down an altitude, connecting it to the x-axis always. That is going to be your reference angle. So for example, let's say that my orange theta here, okay, let's say that my orange theta here, my big angle, let's say it was, let's just say 150. Check this out. You went 150, right? That's 90 plus 60, correct? What would my reference angle be here? 30. Very good. Why? When you have a reference angle in the second quadrant, it's 180 minus the original theta. Literally. Or if you don't want to memorize that, that's fine. You know that you went 150, right? So that's 90 plus 60. Isn't each quadrant 90 degrees? What's 90 minus 60? And now you can work with it. Because have you guys learned what the sine of 150 is? No, but we do know what the sine of 30 is, don't we? Yeah, the sine of 30 is going to be 1, radical 3, 2. It's going to be, and this is a negative down here, so it's going to be 1/2 sine of 130. Sine of 150 is going to equal opposite over adjacent, 1/2. Why? Because I'm using my reference angle of 30. Are you getting with me here, guys? Okay. I'm going to erase this now. And now let's do the blue angle. The blue angle, I go 180, and I go a little bit more. Whenever you have a reference angle, you create a reference angle dropping an altitude to the x-axis, creating your 90 right there. This is going to be my reference angle now. So for quadrant 3, the reference angle is your major theta minus 180. When you have a reference angle in the fourth quadrant, you went all the way around and then a little bit. You drop an altitude to the x-axis, and now that is my theta prime. That is my reference angle. So when you look at reference angles, guys, what you're really creating is right triangles where the right angle is touching the x-axis. You with me here? Because now we're going to practice this, I promise. Does this make sense so far, though? Okay. Now, let's work out some problems. Just find the reference angle here. 300. A lot of people don't memorize the formula, and I understand that. I respect that. But you got to understand that I need you to at least be able to draw this out and quickly. 300 degrees. I want to find the reference angle. Well, didn't I go 270 plus 30, right? So if this little piece is 30, what's my reference angle? 60, and I'll put 60 in green so you can see. That's my reference angle. That's my triangle that I created. Now, if I want to find the sine of 300 degrees, the sine of 300 gives me a reference angle of 60, correct? Now make your triangle. Isn't that going to be negative square root of 3 because it's below the 0? That's going to be 1 because it's opposite the 30. And this hypotenuse is going to be 2, correct? So what's the sine of 300? Opposite over hypotenuse? Negative square root of 3 over 2. Does that make sense, guys? Yes, sir. Hypotenuse is never negative because it's c squared, and a squared value can never be negative. Thank you, sir. Does that make sense, boys? Yes, sir. Yes, sir. Yes, sir, because it's below the 0. Does that make sense, guys? Okay. And you know what? Did I put that in your notes? Yeah, I don't know why I put that value there, though, because I haven't taught you how to do this yet. Okay, I haven't taught you how to do that yet. Let's put, let's say the, I don't know. No, not 185. Let's do 210 degrees. If I got 210 degrees, I'm going 180 plus 30, right? Well, guess what? In this case, the 30 is going to be my reference angle, is it not? Yeah. So if I said to you, what's the tangent of 210 degrees? Tangent of 210 has what reference angle? Guys, it's right here. This is the whole angle of 210. What's the reference angle, though? 30. What's the tangent of 30? Well, 30, this is 1. This is negative square root of 3. And this is 2. What is the tangent of 210? This is negative as well. So the tangent is opposite over adjacent, which is negative 1 over negative square root of 3. So that's going to be square root of 3 over 3. Does that make sense? Okay, guys. Let's continue here. One thing real quick. Remember yesterday I talked to you about all students take calculus? Okay, I'm just repeating it again. You don't have to know this really yet. This is going to be for further further investigation in trig, because when you're setting up your triangles, you could set up what's negative or positive. But in a pinch, I don't even need to draw my angle. If I know what quadrant I'm in, I can tell you if it's going to be positive or negative. If you have your reference angle in the first quadrant, that's it. It's going to be all positive. If your reference angle's in the second quadrant, only the sine and cosecant are positive. If it's in the third quadrant, only the tangent and cotangent are positive. If it's in the fourth quadrant, only the cosine and secant are positive. Let's find the exact value of each trigonometric function. All right, guys. Time to separate the men from the boys. I want the sine of 240. Please pay attention to how easy this is. Draw your angle. 180 plus 60, correct? When I'm doing a reference angle, don't I match it up to the x-axis? So what's my reference angle right here? 60. Done. Across the 60 is a square root of 3 negative, a negative 1 across the 30, and a 2. I just simply made my triangle. What's the sine now of 240? What's the sine of this reference angle? Opposite over hypotenuse, so negative square root of 3 over 2. Done. What's the cosecant of 570? Do I really want to work with 570? Very good. I'm going to find the coterminal. Very good. 210. So I want the cosecant of 210. So check it out. I go 180 plus 30, right? You with me, guys? I drop my altitude with the x-axis, and I have a 30-degree reference angle. So now, 30, I got 1, negative, square root of 3, and 2. You don't know how to do your triangle? You're out of luck for this. What's the cosecant, which is the reciprocal of 210? Guys, come on. Reciprocal of sine. It's going to be hypotenuse over opposite. So this is going to equal negative 2. Yes, sir. Yes. Now, what happens if I give you something like 307? Am I going to be able to get a reference angle that I know? What do you do there? Calculator. Done. Very good question. Thank you, son. Okay, I gotta fly here. Cotangent. Okay, cotangent of 135. I'm gonna go 90 plus 45, right? So there's 45 here. So what's this reference angle then? 45, because 45 minus 90 minus 45 is 45. So is this a 1? Ain't that a 1? And is this a square root of 2? So now, be careful. What's the cotangent of 135 then? Adjacent over opposite, so that's going to equal negative 1. Cosine of negative 300. Pay attention. I got 180, 270. Just bear with me, guys. I'm sorry. So 270, 30 more. Now, remember, my reference angle comes this way with the x-axis. So what's my reference angle? No. If this is 30, this is 60. Remember, that's square root of 3, 2, 1. What's the cosine of negative 300? Adjacent over hypotenuse, so 1/2. Does that make sense, guys? Get out of here. God bless you all. Actually, homework that is on the deadline is valid, except it says do the odds. Do every other odd. And while you guys go to lunch, I'm going to finish up a couple more examples. So please check out the rest of this video. God bless you. Have a great day. Bye-bye. Go. Okay, guys, let me finish this up for you. Suppose that theta is an angle in standard position whose terminal side is in quadrant 3, and the secant of theta is negative 4 over 3. Find the exact values of the remaining 5 trig functions. Well, go ahead and get a little graph out. Okay. You know that the point that this angle has stopped at is negative 4, 3. Okay, so it's in the third quadrant. So I'm going to have to make a third quadrant here. Okay. Actually, let me make this easier for you. Secant is the reciprocal of cosine. So this is the hypotenuse, and this is the adjacent, because that's the reciprocal of cosine. Remember, the hypotenuse is the r, and the adjacent is the x. So what I'm going to do here, what I like to do is, I just go like this. Here's my theta, And I know that my hypotenuse is 4. Hypotenuse can never be negative. And my adjacent is 3. Okay. That's the fourth quadrant. I'm sorry. I'm a ding-dong. Here we go. Here's my theta. My hypotenuse is 4. My adjacent is -3. That's how I got the -3/4. This is not a 3/4/5. Actually, no, yeah, it's not a 3/4/5. This is 16 equals 9 plus, let's say, y squared. So subtract 9. So I've got 7 equals y squared. Square root of both sides. Y equals square root of 7. So this is negative square root of 7. Okay, so since I have negative square root of 7, what am I going to do here? I'm looking for the remaining 5 trig functions. So I know that if secant is -4/3, I know that my cosine is going to be -3/4 because it's just a reciprocal. My sine of theta here is opposite over hypotenuse. So it's negative square root of 7/4. My cosecant is the reciprocal of that. So it's going to be -4 over square root of 7, but I must rationalize square root of 7 to top and bottom. So my cosine will equal -4 square root of 7/7. My tangent of this theta is opposite over adjacent. So that's going to be negative square root of 7/3, which equals square root of 7/3. And my cotangent is that reciprocal of tangent. So it's going to be 3 over square root of 7. But then I have to rationalize. So I get 3 square root of 7/7. So I have the remaining 5 trigonometric functions, all because I just set up my triangle the right way. Nice and easy, hopefully. All right. In a robotics competition, an arm, okay, 4 meters long is to pick up an object at point A and release it into a container at point B. The robot's owner programs the arm to rotate through an angle of precisely 135 degrees to accomplish this task. What is the new position of the object relative to the pivot point? Write that down. Okay, guys, there's a really easy way to do this. So pay attention. It's pretty simple. We know that when we're in standard position, okay, we're going to do this in red so you can see, the arm is 4 units long. So we're going to go ahead and say the arm is 4 units long, okay? That arm now, remember, that arm now is going to be rotated. Let me do it like this. Let me draw this here for you as well. Okay. Now that arm is going to travel 135 degrees. What happened there? Well, I went 90 plus 45. So my reference angle, if I drop this down, my reference angle is 45. The hypotenuse is 4 because that's the length of the arm. Well, this is a 45, 45, 90 triangle. This is a 45, 45, 90. Okay, we know that the hypotenuse of a 45, 45, 90 is s times the square root of 2, which equals 4 in this case. So let's solve for s. Let's find what the side lengths are. This is going to equal, when I rationalize, it's going to be 2 square root of 2. So this is -2 square root of 2, and this is 2 square root of 2. And now I have everything that I need. The exact coordinates, the location, because they want to know what is the new position of the object relative to the pivot point. So they want to know in this circle, because remember there's a circle going on here, they want to know what is that position. Well, that position is x comma y, which in this case is -2 square root of 2 comma 2 square root of 2. And that's how you find your new position. Thank you very much. Once again, the homework is valid, but it's going to be 2 days combined, okay? It's the part 7 and part 8 homework. So it's going to be the 2-2 and the 2-3 worksheets that I gave you guys. Do every other odd according to the numbers that I gave you. Thank you very much. God bless you and have a great day.